to withstand some of the toughest conditions inside. Fire and water working to create steam can be quite taxing on the materials within. With proper water conditions, routine maintenance, and daily monitoring, boilers can last for decades. One way or the other, however, some of the components within can and will fail over time, leaving the owner with a hefty punch list to say the least. In this video, you will see the team at Power Mechanical restore a 1993 Cleaver Brooks 600 horsepower fire tube boiler by replacing the tubes as well as an interior tube sheet. This 3-pass wetback design has an additional tube sheet within that was no longer satisfactory for the stringent requirements the material needs to meet. The tubes within a fire tube boiler can split, pinhole, rupture, and degrade to a point of unsafe operation and need replacing. Owners and operators can sometimes opt to plug these tubes as a quick fix if needed. However, each plugged tube creates a deficit on the boiler's efficiency. Depending on the demands of the application and its upkeep, a fire tube boiler could see several tube replacements over its lifetime. The vessel and tube sheets are made of a material much thicker and generally are not greatly affected from the expansion and contraction occurring through high and low temperature changes. That is not always the case, however, as mentioned. Lack of proper maintenance and oftentimes operators that are improperly trained on boiler starting and operating procedures can lead to a boiler with failed tube sheets and even vessel problems. Front and the interior tube sheets are removed on this boiler. The interior sheet that will be replaced will be laid out on code plate and prepped for cutting. Let's talk a minute about code plate. Code plate is not simply just a sheet of steel. ASME code material is held to very strict standards of compliancy and composition. This material has been traced throughout the production, quality assurance, and shipping cycle to verify the critical components that affect the steel's responses to various conditions. Material composition, heat exposures, and all handlings are tracked and remain part of the paper trail that accompanies repairs when dealing with this material. These standards are a system that ultimately protects the end user of the boiler by more or less proving the material's credibility. Throughout the process, there will be multiple checks occurring to ensure the fit is proper and the tube openings are lined up correctly. The front sheet will be set aside for later replacement. After the layout is confirmed and marked on material, it will be taken over to the Power Mechanical machine shop, where a machinist will spend several hours cutting each hole cleanly and precisely, carefully lining up the bit for each cut so to ensure the tube opening is precisely where it needs to be. A misaligned punch here would become costly in a hurry. The oil spray, or quenching as it's sometimes called, keeps the metal-to-metal contact cooled and in turn prolongs the life and efficiency of the cutting bit. Once the tube holes have been punched and deburred, the openings will get a final cleaning to a near polished finish and offering a smooth fit. It will then be taken back to the fabrication area where it will again be measured and checked prior to cutting. The cutout will be done with a plasma cutter, which produces a fairly clean cut. All edges will get a cleanup and a proper bevel to accept the weld. The welding of coated material such as this is as important as the material itself. A substandard weld or incorrect fit will more or less become the weakest link in the pressure vessel. Fitters will carefully position the heavy steel sheets into place to ensure proper alignment for the steps yet to come. As mentioned earlier, the weld procedure and its integrity are parallel in importance to material composition. The steel will be preheated to an ASME specified temperature prior to any welding occurring. These tested welding procedures diminish the chances of the rapid expansion and contraction, which in turn could lead to a premature material failure. Along with the amount of welding required and the ASME procedure, several hours will be spent by certified welders fusing the void between the sheet and the vessel. A proper weld is not simply filling the gap with metal. The two surfaces to be welded are brought quickly to a temperature that creates molten metal. The molten metal is then pooled and mixed with the weld metal to create a fused solid surface. In most cases, with proper techniques, the welded area will actually be stronger than the base material itself. Now that both tube sheets are fit and welded into place, the tubes can be fit into the boiler. It's here where you can see the importance of proper layout for the tube sheets. Misaligned fits would be a major setback for this rebuild. The boiler mechanic will position each tube and use a tube expander to create a flared watertight seal at the joint of the tube and tube sheet in a process commonly called rolling tubes. Once all the joints are sealed and double-checked, the boiler's vessel portion will for the most part be back to operational standards. Preparations for customer shipping will continue and have the boiler ready in a nearly like new condition upon receipt. This 25-year-old boiler